Hello, let's continue our Sudoku adventure with Something is Off Here by Jaze. So this is a leftover puzzle from our doublers week. So there are doublers in this puzzle, in addition to region sum lines, but let's go over the rules carefully in case you're not familiar with those. So we have normal 6x6 Sudoku rules. So in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. Additionally, we have these region sum lines in the grid. So the way region sum lines work is we're going to split those up by which box they occupy. And so I colored it that way, right? This line goes through several boxes. So within each box, it's going to have the same sum. So green sums the same as purple, sums the same as blue, sums the same as orange. Now there is a doubler rule, so don't worry, that makes it possible. If a line re-enters a box, then it starts a new sum. So that's important for this line here. So we actually split this up into 3 different sums because it re-enters the box. So it starts a new sum when you do that, which does mean all 3 of these are the same value. How does that work? Well, we do have doublers in the grid. So arbitrarily pick this one. If this cell was a doubler and I had a 2 in it, then for the purpose of the region sum line, it counts as a value of 4. So this would give the region sum line a sum of 7, not 5, 7, because the 2 is doubled. And so all of these would then need to have a sum of 7. Now for doublers, we don't know where they are. We have to find them. There are exactly 6 of them hidden in the grid. There is 1 for every row, 1 for every column, and 1 for every box, kind of like Sudoku digits. So once I would have this one placed, I could not place another doubler in any of these cells because we cannot share the same row, column, or box. Additionally, every digit is only doubled once. So if I were to put a 2 here, I cannot double the 2 again anywhere else. That's against the rules. So once you have a doubler on a 2, none of the other 2s are doublered. There's another way to put that. And that should do it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, well, I think it's pretty clear we need to start with this line because there is no way this is not doubled. The minimum we can put here is 1, 2, 3, 4. And that adds to 10. And so there is no 10 digit. There's not even a 7 through 9. So this has to be doubled. And we have to get to at least 10, so we're doubling a 5 or a 6. So now none of these are doubled. All right. Can we actually double the 6, though? If this was a doubled 6, that means this sum is 12. So it would be 2 more 6s. Definitely not going to work. So this has to be a 5. So that adds to 10. There is only one way to add to 10 in 6x6. That's 4 plus 6. These are from 1, 2, 3. Now that this is 10, this actually does have to be the minimum 1, 2, 3, 4, which means it can't have a doubler because doubling it can only make it bigger. We need to say minimum. That puts a 5, 6 here. Okay, so we're going to be doubling the 6, and it's definitely not here because these can't add to 12. So we're going to be doubling the 6 here. So these add to 12. We can make these gray. 2 plus 3 is 5 since there's no 4 on here. That's a 1. It's not a 1. All right, good progress. I think I want to think about this one here, right? Because it has to involve a doubler because we have to have the same digit the same value 3 times on it. So these 2 are going to be the same value, and this one's going to be the doubled one. Because obviously doubling this one doesn't help. These 2 still see each other, right? So these 2 are going to be the same digit, and then this is doubled. So these are not doubled. And the value, we can't double bigger than 3 because it needs to be a single digit here and here. So these are from 2, 4, 6. Yeah, these are even always. Okay, that's good. So it's going to be either like 2, 2 with a 1 or 4, 4 with a 2 or 6, 6 with a 3. Oh, but we have a 4, 6 pair in here, so that's quite nice. So that's a 2, that's a 2, that's a 1. These are not 2s. That places the 2 here. So this is a 3, 5 pair. What do I want to look at next? Okay, well, the biggest this can be is 8 because I can't double the 5 or 6 anymore. So even if this was doubled, it would only be 8. So we can't put a 6 on this line. In fact, we can't put a 6 on it because of Sudoku. Let's just put a 3, 4 here. This adds to 8. So the biggest we can do is 8. So that is what we're doing. Okay, that's a lot simpler. I was trying to place the 6 in this box, but I did in a weird way. All right, that's a 1. That's okay. I think you got what I was saying. This is a 5, 6 pair. All right, we have a lot of stuff done over here. All right, these can't be doubled because of the doubled 4. These can't be doubled because of the doubled 1. I should have drawn those earlier. This has to 12, this has to 10. I'm not sure. Let's see. These add to a minimum of 7 because this can be 3, 4 minimum. So that means this is maximum 3 and it can't be 3. So this is 1 or 2. Oops. This is 1 or 2. All right, we have 2 doublers left, and they're going to be the 3 and the 2 and the 3 need to be doubled. Okay, we have this 2 here. So we're not doubling the 2 here. We're going to double the 2 here. So one of these is a doubled 2. That means one of these is a doubled 3. And this can't be the 3. There we go. So this is the doubled 3. That's not a 3. Nice. That's 2 and 3. That's not a doubler. That's a doubler, and that's not a doubler. And this is the doubled 2, which puts that a 1 there. So these add to 9. 4, 5, or 3, 6. So 3, 6 would go this way, and 4, 5 goes either way. Oh, nope, sorry, that's not 5, that's not 4. Okay, that's a 6. So these add to 6. Can't use the 1, so these are 2, 4. We know the order. That's a 3. Whoopsie. These are from 1, 5, 6. The 5 goes there. That's 6 and 5. That's a 6. So 6 goes with 3. That's 4 and 6. That adds to 10. The 5 goes down here, and the 2, no, not the 2. The 4 goes up here. That's 1 and 4. We're left with a 1 and a 6, and we're done. Sweet. All right. Cool puzzle, Jaze. Yeah, that ending there where we had to double the 2 and 3, that was neat. What else did I like? This was just fun. A lot of this was forced. This just becoming 8, which forced this to be double 4, was also neat. All right. Cool. Yeah, I think that flowed very nicely. It was always pretty clear where to look next. But also some intricacy. There were quite a few deductions we had to make. So I enjoyed that. Hope you did as well. And if you did, then why not leave a like, subscribe, and a kind comment below.